Let's talk about how to go about solving uh, 2.1.20. It's looking at a displacement function that is 9 sine of 3t, and it's wanting us to find out the instantaneous rate of change at pi by finding the average rate of change from pi over 2. Sorry, it wants us to find the instantaneous rate of change at pi over 2 by finding the average rate of change from pi over 2 to values after pi over 2. Starts off wanting the average rate of change from pi over 2 to pi. And so when I evaluated the position function at pi over 2, it's just 9 sine of 3 pi, and the sine of 3 pi is 0, so it gave me a 0 for that one. I subtract from that 9 sine of 3 pi over 2. Well, the sine of 3 pi over 2 is negative 1. When we multiply that by 9, we get negative 9. So I get 0 minus a negative 9, which is positive 9, divided by pi over 2. And I put my answer to 5 decimal places. I've left the rest in there so I can show that on my calculator for the next few steps. So on this next one, if I want the average rate of change from pi over 2 to pi over 2 plus 1, then all I need to do is evaluate my function 9 sine of, and I'll say 3 times the group, and it's going to be pi over 2 plus 1. So I'll say, all right, pi over 2 plus 1. All of that's being multiplied by 3, and all of it's inside of the sine function. So I can get that in there. This should give me the first term in the numerator of this fraction, and it does. Now, there's no need to worry about the second term again. It's always the displacement at pi over 2, so it's always going to be minus a negative 9. So for this one right here, I would go in, and I don't want to make any rounding errors, so I will put every single solitary decimal point, or decimal place, I should say, 8.9099, and then we get 32469. I'll add 9 to that, and I'll divide it. We know there's a tenth of a unit differential in these two horizontal components. So now when I add 9 to this answer and I divide it by 0.1, whew, I'm getting 179, huge jump from the previous average rate of change, 179.09, and it asks us to round our final answers to 5 decimal places. So I get 179.09932. That should be the answer that my lab is wanting for this one. For the next one, I'll go through a very similar process. We know the first term in the numerator is what we're finding each time, so we know we're going to have that first term. We're going to be dividing by 1/100th of a second here, sorry, 1/100th of a horizontal component, then 1/1000th of a horizontal component in the next one, and dividing by 1/10,000th of it in the last one. So trying to get very precise answers here. Now, to get the y values here, or sorry, the numerator values, I'll just go back up and edit this one instead of pi over 2. Oh my. Notice what I did. I said pi over 2 plus 1 instead of pi over 2 plus zero point 0.1. Ugh. So I'll have to go back in and redo that one. I'll insert in a 0.1. And let's see. Okay, that's giving me an answer that makes more sense. So this one right here, I did bad decimal place error, John. We'll go in. So the idea was right. The calculator work was wrong. Boo me. So I have zero point 0.1 in the denominator. My numerator is going to be negative 8.59. I thought that was a dramatic change. 8 0.028,402. We know we're adding 9 to that. And then I can go in and say, well, once I add 9 and then divide that by 1/10 of a unit, boom, I'm getting 4.02. No, why did I say 02? 4.01. We can't round it to 2 decimal places. 972. So there is a 2 in the answer. All right, 4.01972. The next one now. I'll say, well, okay, I'll pull back up my sine function here. Instead of pi over 2 plus 0.1, we have pi over 2 plus 0.01, so I'll insert in a 0. The sine of 3 times pi over 2 plus 0.01 is giving me negative 8.995950304. We're adding 9 to that. And then we'll divide that answer by 0.01. And when I do that, I'm getting 0.40497. Okay, so 3 down, 2 to go. This next one was wanting us to find the average rate of change or average velocity from pi over 2 to 1/1000th of a unit after it. So I'll say, well, all right, my function here, I'll pull it back up and I'll say pi over 2 plus 1/1000th. I'll insert in another 0. I'm getting negative, and please remember, you're going to have to put every single one of these or else it's going to throw your answer off. I'll have negative 8.49s and then 595. I'll add 9 to that and divide that answer by 1/1000th. When I do that, I'm getting 0.0404. Ooh, but if I want to round to 5 decimal places, it's going to be 0.0404. But then instead of a 9, that 9 is going to round that 9 up to a 10, which moves this up to a 5. So it's just going to be 0.0405. And then you could put a 0 on the end of that. Now, for the last one here, and I think I already know the pattern. The pattern, this should be going to 0 because it seems like the numbers getting smaller and smaller each time. This was 0.4, now it's 0.04. I'm expecting this next one to be 0.004, but we'll see. When I try that, I bring back my function and I need to evaluate it at 9 sine of 3 times pi over 2 plus 0.0001. When I do that, I'm getting a negative 8 with a ridiculous amount of 9s after it. Let's see. So it's 1, 2, 3, 4, 5, 6 9s. Followed by 595. As in all the other ones, we're subtracting the sine of pi over, sorry, the position function at pi over 2, which is going to be plus 9 again. We will divide that by the difference in the horizontal component, which is 0.0001. And when I do that, I'm getting 0.00405. Yeah, that's 5 decimal places. 0.00405. And then let's see. So in this problem, notice if I hit show completed on my end, they should have the same answers as what I just got here. So the 5.72958, the 4.01972, yes, the 0.40497, yep, 0.0405, and they put a zero at the end of it, and then 0.00405. Now, what the point of these average velocities over a smaller and smaller a region is trying to get you to see is what is the instantaneous velocity or the instantaneous rate of change at t equals pi over 2. And we could say, well, at t equals pi over 2, clearly it's approaching zero because the closer the time interval gets, the smaller and smaller and smaller the y value or the position value is getting closer to zero. So the value is getting closer and closer to zero as t approaches 2. All right, guys. Sorry, I made that initial slight mistake on the calculator with putting a 1 instead of a 0.1 in there. These problems can be tedious, but they do serve a purpose. They're getting you to hopefully appreciate the concept of a limit.